Students, today we will cover a topic from Unit 4, that is Introduction to Lock-Based Protocols. Now, what are locks? A lock is defined as a variable associated with a data item that describes the status of the item with respect to possible operations that can be applied to it. It prevents access to a database record by a second transaction until the first transaction has completed all of its actions. Now, locks are put under two categories. There are two types of locks: binary locks, and second one is shared exclusive locks, which are also known as read-write locks. Now, in binary locking, there are two states only. First state is state 1, which is known as locked state, and second is 0 state, which is known as unlocked state. So, if an object of a database table, page, tuple, or attribute is locked by a transaction, no other transaction can use that object. A distinct lock is associated with each database item. If the value of the lock on data item X is 1, item X cannot be accessed by a database operation that requires the item. And if a data item X is unlocked, any transaction can lock the object for its use. Now, two operations are used with binary locking, that is lock item. In bracket we have to write the name of the data item, suppose X, and second operation is unlock item. In bracket we have to write the data item name. So there are some rules which we have to follow during binary locking. First rule is a transaction T must issue the operation lock item A before any read item A or write item A operations are performed in transaction. So this means that before doing any operation, read or write, a transaction must issue the operation lock item on the data item which the transaction want to use. Second rule is transaction T must issue the operation unlock item A after all read item A and write item A operations are completed in T. This means after completing all the operations, the transaction must issue the unlock item operation. Third rule is T will not issue a lock item operation if it already holds the lock on an item A. Next rule is T will not issue an unlock item A operation unless it already holds the lock on item A. And last rule is at the most only one transaction can hold the lock on a particular item. No two transactions can access the same item concurrently. So these are the rules which are followed during binary locking. There are some advantages and disadvantages of binary locks. Like binary locking is easy to implement, but it is restrictive to yield optimal concurrency conditions. Second is DBMS will not allow the transactions to read the same database object even if neither of the transactions update the database. And last is at most one transaction can hold the lock on a particular item. No two transactions can access the same data concurrently. This we have read earlier also. Okay. Only one transaction can hold the lock on a particular item at a time. No two transactions can access the same data concurrently. Now, after binary lock, second type of locking is shared or exclusive locking. A shared exclusive or read-write lock uses multiple mode lock. In this type of locking, there are three locking operations, namely read lock A, write lock B, data item, you have to write the data item name, and unlock operation. So the operations are read lock, write lock, and unlock. So a read locked item is also called shared lock. So read lock is shared lock because other transactions are allowed to read the item. A write locked item is called exclusive lock because a single transaction exclusively holds the lock on the item. A shared lock is denoted by S and exclusive lock is denoted by X. So the operations we can write like this: lock underscore S means it is a shared lock, and in bracket we have written the data item name A. Lock underscore X means it is an exclusive lock on A, and third operation is unlock A. Now there are two approaches to write concurrency control algorithms: pessimistic approach and optimistic approach. Now as you can see the diagram, pessimistic approach is further divided into locking protocols. In locking protocols, we will discuss two-phase locking and non-two-phase locking. Non-two-phase locking is further divided into graph-based locking and timestamp-based locking. So these we will discuss in next video. Today we will discuss only pessimistic approach and optimistic approach. Now pessimistic approaches in which the transactions are delayed if they conflict with each other at some point of time in future. This is pessimistic approach. Now during pessimistic execution, the validate operation is performed first. If there is a validation according to compatibility of lock, then only read, compute and write operations are performed. So the sequence which is followed in pessimistic approach is validate, then read the operation, compute the operation and write the operation. So this pessimistic approach is very simple. We have to first validate and then read the operation, then compute and then write. Whereas in optimistic approach is based on assumption that conflicts of operations on database are rare, and it is better to run the transactions to completion and to check for conflicts only before they commit. So in optimistic approach, it is assumed that the conflicts are very rare. So no checking is done while the transactions are executing. Also note that this method does not require locking or time stamping techniques. Here a transaction is executed without restrictions until it is committed, and it allows conflict checking at the end only. So this approach works on a premise that conflicts are rare, and in this approach the sequence followed is first the operation, we read the operation, then compute, and after that it is validated before writing or updating. So the sequence is read, compute, validate and write. So we have discussed pessimistic and optimistic approach. In next video we will discuss the various locking techniques of pessimistic approach, that is this, as you have seen, two-phase locking and non-two-phase locking, and further non-two-phase locking is divided into graph-based locking and timestamp locking. Thank you.